Hi, my name is Jean Véville. I'm Director of OEM and Channel Sales for Accelera here in EMEA, and presenting to you for Charbax the company and what is our value proposition. So we are today the largest fabless AI semiconductor company in Europe, providing an alternative for AI inferencing to NVIDIA. We have developed the first inference chip on the market that provides 214 TOPS for 6 watt typical power consumption and a fraction of the cost of NVIDIA.
That's a lot of power. That's a lot of performance, right?
Absolutely. That's about the performance of a Jetson AGX Orin, which is, let's say, top of the line when you look at the NVIDIA portfolio.
But you're just using 6 TOPS? Six. What is the power consumption that you use?
6 watts.
6 watts. And what is the power consumption for an equivalent NVIDIA?
Well, typical equivalent for NVIDIA GPUs will be, say, an A4000 or A2000 ADAD, which are GPUs that would range around 100 watts or 70 to 100 watts, yes. So, and we're an inference-specific chip, so it's very important to know that in AI you have 2 domains. You have the training of the model that is typically done on GPUs, and then once you have trained your model, you have the usage of the model. So this can run on different form factors.
What do you see here?
M.2, and we have a PCIe.
Is it the same chip?
It's the same chip, yes.
240 TOPS right there?
214 TOPS, yes.
214 TOPS.
And then we package it also in a PCIe 4 chip interface, which can fit within any motherboard. So we're helping out running the inference, and we get the video from the motherboard.
You have 4 of them in there?
And we have 4 of them here. And then basically here we show a demo that demonstrates the power of our inference platform. You have an 8K camera up there, and the 8K camera is sending out the video feed to the motherboard that then helps treat the inference directly on the 8K native resolution. So it's very, very intense in inference world to treat such a high resolution. And with our technology, you're able to see very, very tiny objects very far away because you're using out the 8K resolution as the model input. And this is why Accelera platform today is leading this AI revolution in inference. And
so here at this booth at Embedded World, are you showing this in use for some really powerful edge AI solutions?
Yes, we do have a number of different demos here on the show. We're demonstrating with some of our partners like OnLogic here. We have different fanless systems that helps to run inference at the edge.
A bigger one here?
SysLogic system.
How many, what performance could be in here? Is multiple of these in there?
This one is running 1 chip, but we can have multiple of them as long as we have 4 PCIe lane or an M.2 interface which can sustain the power consumption and the bandwidth necessary to have the inference.
What's this one showing off?
This one is with one of our partners called Control. It's running a theft prevention system for like supermarkets. So imagine you're scanning out your different items. Let's start over. So you're scanning out your different.
Yeah, you need to scan something else.
Yes.
That's fine.
So let's start again. So you're scanning out your different items, and basically the idea is to avoid people from just faking out the scanning and then automatically sending out an alert when they don't scan the system. So the idea is here to avoid theft prevention. We're the only chip on the market today that can run both computer vision and also SLM, small language model. So we have a demo here that runs on Llama 3.2, 1 billion parameter, that helps to have speech to text and then text to speech and running our inference for the generation of the answer. So say for example,
that's just 1 billion parameter.
Just one, but we can go up to 8 billion parameter on this chip, and we are developing a new chip that is coming out this year that we have run bigger model with bigger number
32 billion, 40 billion?
Maybe.
We'll see.
You will see.
What I would like to see, but I mean, I don't really understand completely how it works, but
yes.
When there's a mixture of experts model that's, let's say, 128 billion parameters, I don't know, 200 billion parameters, but you only need 10 billion active at the same time, you know? You only need maybe a little bit more than 10 billion. And if your chip could run that, but have all the mixture of experts on memory at the same time, so it would be super fast to, you know, like what I mean? So you don't need to have a $5,000 MacBook Studio, but you can actually do it with a $500 Accelera powered edge device.
So typically, the LLM world is starting to boom at the edge. We can run model up to 8 billion, like I said. It's typically a good, you know, envelope in terms of having industrial application that can run a decent.
For 8 billion model is like real-time performance, right?
Exactly.
But you can do a bigger model slower, I guess.
We can do, no, we cannot do bigger model because we cannot fit them inside the memory, but we have what is coming out next, which is going to be our Europa platform that is released this year, that we're presenting.
Is there?
Over there?
No.
Yeah. So Europa will be a new generation of our product line. So Accelera, like I said, is fully European. At the moment, we will package it in a PCIe single chip form factor. And essentially, this will address very high premium edge. So robotic application, VLMs, etc.
629 tops.
629 tops. And then we will be able to run it also for more LLM application with
bigger than 8 billion.
Than 8 billion parameters.
But you don't say how many billion yet.
Well, let's say the sweet spot will be between 8 billion and up to 100 billion parameter.
Oh wow, that's a lot of range potential. So because as I understand, you need to keep all those billions of parameters in memory, otherwise it doesn't work, right? You can't just load them from the SSD slowly and stuff like that.
No, it's the memory that is associated to the chip. So the chip helps run the inference, and then we have DDR5 on board that helps to accumulate itself the.
Isn't it possible that you design a board that just have tons of memory? Doesn't need to increase the performance, but just have more memory.
I cannot answer this question. It's about.
I don't know how it works. I don't know how it works. Sorry.
Understanding.
Yeah. And what's happening here?
So here we are showing another demo on our Metis board, Metis chip, which is the first AI inference chip we developed. That is a container check application. So essentially, it's developed with one of our partners called Gotilo. So imagine you're changing the container. It will automatically detect the container. If there is any rust or any scratch on the container, it will automatically address it and let know the operator of the port. This is another example of how you can enable Accelera Metis at the edge today in production. We have about more than 500 clients to date. We have raised significant amount of money, and we're, as I said, fully European. We are providing an alternative that not only help run a very high performance, low power, low cost, but also de-risk supply chain for Europe.
And you will support the robots. So yes. You have a little, you have the chip in there, and you're helping the robot to go around, be autonomous?
Yes, we're showing here one of our partnership with Kudelski. So essentially the robot is going to be looking for the teddy bear family, and is here to
looking for its
them.
baby.
Exactly. And essentially it's going to continue rotating like this on the platform. Of course, it can do a lot more than rotation like this, as long as it doesn't see. And then when it finds the bear, you can see on the screen over there, then it will essentially make sure it locks in and it's safe.
Nice. And what are you showing here and here? I see a rock chip. That's
yes.
A very good 3588 maybe.
Exactly.
And then
so
together with the Accelera.
3588, so that's the CPU that will get in the video stream, do the pre-processing, send us the pre-processed video stream, and then we'll run the inference on our chip and return the inference result to here.
So this is
one of our products called single board computer, Metis compute board, that currently can be easily accessible on our website. So everything, we have a web shop, can be bought directly on the website.
So right there, people can get the Metis. Because this is a very great ARM SoC, it's a square shape, and you're more like rectangular. Is there
yes,
like a reason why? Is there a reason why it's long like this, or you cannot say?
I think, generally speaking, the reason is to fit into an M.2 form factor. So the beauty of it is that we can fit inside any NVMe of 2280. You can take a computer, x86, ARM, and XP, any sort of CPU that you have, you plug it in, and then you can run your inference on our chip.
Can you say just a little bit more while we look at this? what is special about the design of your AI accelerator compared to everything else?
Sure. So one of the beauty of our technology is we have two foundation blocks. We have digital in-memory computing, which is one of our pillars that is essentially a very dense memory interlaced inside the chip, and that helps to process matrix vector multiplication. MVM, matrix vector multiplication, represents 70 to 90% of operators today when it comes to computer vision. So with this chip, we have very, very high performance while keeping a small size, so low power consumption, low cost. And the second pillar of our technology is RISC-V. So we're deep into the RISC-V architecture, which is an open source instance of silicon design. And we have inside an orchestrator that helps to address the different AI cores we run on our chip. What is important here is you don't have one, but you have 4 AI cores on the 214 top. So you can parallelize different models, or you can cascade them. Because in a real life example, you never have just one model running. You have 1, 2, 3, or 4 models that will run either in parallel or in a cascaded mode.
So the RISC-V is orchestrating?
The RISC-V is orchestrating the different cores, so you can either mutualize them for one model, or you can say, I want to run different model on different core. And of course, if you need more processing power, you can have multiple M.2 on your host.
And what did you consider when you went to Europa? What did you even more improve and more what can you say? What are you allowed to say?
Well, let's say that Europa is the big sister of Metis. It's addressing more towards premium edge, robotic application, contextual understanding like VLM, and of course the LLM market. So this is where we are right now. This chip is planned for release this year, and we definitely have a lot of market traction and addressing the enterprise AI market.
Is there any chance you can make like 10 million of these and power all of the AI needs for Europe?
Well, that's the plan. So let's hope that all the market start to use Accelera, either Metis for edge, 2 to 6 watt power consumption typical, and Europa, which will be more for LLM and premium computer vision application.
Could I launch a bunch of these into space? Is it going to be a right place to do the inference, right?
That's
Some people say that.
Question. Actually, we have a strong partnership with the European Space Agency, which we are working and collaborating for long-term partnership. One of the key aspects of our chip is that we are here for the industrial world also, and we have a long-term availability and wide temperature range. So the company itself provides a product that is ruggedized and that can be used in the long term, which is much appreciated for the European Space Agency and also from a sovereignty standpoint, of course.
Sovereignty and also power consumption. It could even become regulated in Europe, that you can only use Accelera because otherwise you're wasting power. I'm joking, but you know what I mean?
Well,
you have to have the best
extreme, but,
performance per watt. If you really show a big difference.
I think I think what the market is realizing is that there is a need for inference chip. Today, everybody uses GPU or GPU-like technology for inferencing when there is actually alternative for pure inference. And this is what we bring to the market, is the first European chip that can compete with NVIDIA products, that is really focused and optimized to reduce your cost of ownership and basically optimize the inference workloads at the edge.
And there's a French company called Mistral.
Yes.
And there's also a bunch of Chinese very cool open source AI models.
Yes.
I wonder if you work with some of them to customize the model to make it perfectly fit on the chip, right? To maximize exactly what you can do.
I have to say that today, one of the beauty of our technology is that we have a compiler, a Voyager SDK, that helps to compile models from computer vision, trained model on GPUs. You get the weight file and then you convert them to run optimized on our Metis chip. This is a very simple tool chain that does a conversion from FP32-like model to int8 with FP32 accuracy. And essentially today, the beauty of our system is that you can come, if you have the subset of operators supported by our SDK, you can compile the model and it will run on our chip. So At this moment of time, we don't particularly work with any specific model maker, but we have very strong connection, of course, with Ultralytic. That is the state of the art when it comes to computer vision today.
Because I guess you can compile it for it, but I also guess if you did think about the model design all the way from the beginning exactly to maximize the performance, maybe that could get even more out of it. I don't know.
Yeah, maybe. That's an area that we can, of course, evaluate and continue developing. I think we have, like I said, very strong partnership with Ultralytic, and we are at the moment,